Hello, hello, and one more hello. Wanted to thank you, whoever gave that one like, much appreciated, as YouTube pushes the content more if you get some interactions. Now we're going to do some Codewars challenges today, like advertised. This is probably my fifth live doing live challenges. I'm going to be monitoring the chat from time to time just to see if anybody says hello or any questions. But yeah, I will just look at it from time to time as I will be focused on the challenges. So let me switch the camera so that you guys can see the screen as well. All right. So I think today we're going to be doing again maybe a few 7 Caillou challenges, and then we're probably gonna try one or two or more of 6 Caillou depending on how much I feel like doing challenges. Let's um, let's look at this one. I usually don't like to look at. I usually don't like to look at challenges like this that are like too long over this description, but let's see if we can understand this one fast. If the explanation is not too good, I will not do it because I don't like to read long challenges. The accounts of the Fat to Fit Club associations are supervised by John as a volunteered accountant. The association is funded through financial donations from generous benefactors. John has a list of the first and donations, which is an array of the donations. He wants to know how much the next benefactor should give to the association, so that the average of the first n plus 1 donation should read an average of 30. After doing the math, he found 149. He thinks that he made a mistake. Could you help me? So basically, what the function should do is should receive an array with the first n donations, and this function should return how much the n plus 1 donation should be, so that the average of all the donations would be equal to 30. Alright, the function new average of array and nav should return the expected donation. What is nav? Like nav is like how much the average should be. Should return the expected donation rounded up to the next integer, so it should be to the seal. That will permit to reach the average nav. Should the last donation be a non-positive number less than 0, John wants us to throw or raise an error or return nothing in Haskell, return none. So we can throw an error if the donation should be less than 0 or, less than or equal to 0. Notes: all donation and nav are numbers, integer or floats. R can be empty. See examples below and test samples to see which return is to be done. I don't think we need this. So I'm going to, before I start the problem, let me see if anybody said hello. Greetings, Mr. Julian, the recruiter. How is it going? How is your journey going? What have you been up to, mate? Alright, so let's copy this function. Now somebody was asking me in one of the posts that I put on Facebook advertising this live, was asking me if I use EX6, and I do use EX6 a lot in this YouTube videos, but as you can see, the functions that they give here usually are in the older form, which is before EX6. In EX6 we would use array functions, which you would rewrite this function like this. You would say const new average equals to this and this. And if you return just one thing, then you can write it in here. Otherwise, you can do something in the function and then return something. And we have to put these parameters. So this is the array of the donations, and this is the what the average should be. So we need to return how much the n+1 donation should be. Okay, so what we want to do is, first we want to get the length of the array. I'm going to write the uh, short version, the longer version first, and then we can optimize if we want. But sometimes it's nice to write a longer version that it's basically very easy to understand from the way you write it. So what we want to say, we want to create a variable that you can, actually you don't need to change this, const number of donations equals 2, and it would be array length. That means this is how many donations have happened until now. Okay, and then for the average of this donation to be new average, then the total sum should be const total sum for average should be basically the number of donations plus 1 multiplied by the new average. All right, number of donations plus 1 multiplied by, actually what it should be, yeah, multiplied by the new average. Is it by, no, so wait, what we have, we need the new average to be this. So what we need is the sum of all these things plus that thing divided by new average, actually divided by number of donations plus 1. It should be new average. Okay, so what we need, we will need something like this. We will need the sum of the array. So let's put sum of array. Let's make the sum of array that is it is at the moment of all the donations. So let sum of array equals 2, and we're gonna use the reduce method to sum up all these donations. So I'm going to say r reduce. If you don't know how to use the reduce method, I do have a series of videos on it that explain this in detail. So then we're gonna say sum current, and then we want to return sum plus current, and this is gonna basically sum up all the elements from this array, and then we will need the new sum divided by numbers plus of donations plus 1 to be new average. So we basically have to find the x. So what we need basically is for sum of array plus x divided by, so x would be the number that should be donated, divided by number of donations plus 1 should be equal to the new average, right? So now from this we can find out the x. What we can find out from this is that the sum of array plus the x should be number of donations plus 1 or new average. So should be equal to number of donations plus 1 multiplied by new average. And then to find out the x, basically the x would be this minus sum of array, right? So now we have that. Actually we can say const new donation is equal to this. I can take this out and can say const new donation equals to number of donation plus 1 multiplied by new average minus the sum of the array. Okay, and now what we can say is we want to say if new donation is less or equal to 0, we want to throw new error donation must be, I don't know if we have to say here something here. So we're doing this if it's less than or equal to 0. Otherwise what we want to return is basically mat seal, and we use mat seal because if it's something that's I don't see how. Oh, because the new average is probably something that can have like something like 233 or 4021. So basically here what you want to do is basically make it, if the result is something like 1050, we want to return 11 and so on. So we want to return mat seal of new donation. So let's see. This seems to be working. Let's attempt it. Reduce an empty array of no initial value. So what's happening here is we're trying to reduce an array that doesn't have nothing as a length, and we're getting an error here because usually in reduce, when you use reduce, you usually give a starting value here. Like for example, when you make the sum, you give the starting value of 0, but if there is actually something in the array and you don't give an initial value, it just gets the first value of the array as the first initial value. But the problem here is if you give an empty array, there will be no initial value. So we will have to start this one from 0 so that we don't get that error. So let's attempt this again. And this works. Alright, I'm gonna have some coffee. Now if you have any questions, you can always ask them in the chat and I'll be happy to respond if it's within my capabilities. Alright, let's have a look at another one. Strange mathematics. Oh, like I told you guys, I don't like these ones that have long explanations. But let's look a little bit. In a certain kingdom, strange mathematics is taught at school. Its main difference from ordinary mathematics is that the numbers in it are not ordered in ascending order, but lexicographically as in a dictionary. First by the first digit, then if the first digit is equal by the second, and so on. In addition, we do not consider an infinite set of natural numbers, but only the first n numbers. So for example, if n equals 11, then the numbers in strange mathematics are ordered as follow: 1, 10, 11, 2, 3, 4, 5, 6, 7, 8, 9. Alright. So first value the first number. Okay, help your student to learn this science. Write a function that receives two integer numbers, n, total amount of numbers in stage mathematics, and k, number from sequence, and returns the location of a given number k in the order defined in strange mathematics. Alright. I don't know if this seems just 7 Caillou difficulty, but let's see. Maybe I think it's probably more difficult than it actually is. Let's see. For example, if n equals 11 and k equals 2, the function should return 4 as the answer. Input of n could be between 1 and 100,000, and k could be between 1 and n. Output should be the position of the number k in sequence of the first n natural numbers in lexicographical order. Numbering starts with 1. This one I find it pretty weird. So we may have some problems with this one, but let's try it. Okay. That's the thing, that you can work as a developer for like over 2 years and then you get something that you never had to deal with, this kind of weird thing. I'm going to write this one as an arrow function just to keep the promise of using AX6. So I'm going to say const strange math is equal to, we have n and k. I'm just wondering if there's something like, here we need something like this. If there's something that, if there is a like a pattern that we can see. Mm, 1, 10, 11, 12. So I'm just thinking, if you do have an ideas, you can put them in the chat, because some people just may come up with an idea that doesn't come to me in the moment. Um, let's see in the, I think this has the discussion. Let's see what people say. Yeah, he's saying this is the first 7 Caillou problem I'm attempting. This seems like a huge jump in difficulty to me. Would you say this kata is normal for 7 Caillou or especially hard? And he's saying it's harder than most 7 Cailloux. Katas that have been approved recently tend to be harder. Try sorting 7 katas by criteria other than newest and see how difficult you find those. Yeah, I don't know. But anyway, let's have a think about it. It might not be worth it to stay on the live and solve this one, because if I stay like 10 minutes to come up with an idea, which sometimes it happens, sometimes it can take you like an hour or 2 hours to come up with an idea for something that's like a bit more weird. So if I don't come up with a good idea in like 2 or 3 minutes, we'll have to change the problem, because I don't want to stay on the live without doing any coding for like long time. All right, so we would have this. How many numbers? 1, 10, 1, 1. Okay, this is a very weird one. Anyway, I think I'll leave this one for maybe another live, so I don't stay on the live and think too much about it. So let's pick other ones for now. Presents, let's say this one. What is going on? All these problems with really long descriptions, which I don't like. Don't like to read a lot of text. Let's look at the issues as well, because like this one says 6 issues reported. Alright, let's get some of triangular numbers and let's see what they say. Okay, your task is to return the sum of triangular numbers up to and including the nth triangular number. And triangle number, any of the series of numbers 1, 3, 6, 10, 15 obtained by continuous summation of the natural numbers 1, 2, 3, 4, 5. 0, 2, 0, 2. I don't know what they mean. What? 1, 3, 6 plus 10. So, thank you very much for the like. 1, 2. Wait, so what is this? You got 1 and you have this 0, 1. And you have 2 and you have 0, 3, which is this plus this. And how is this 6 now? I don't get it at all. Let's see if a better explanation for triangle numbers. What are triangular numbers? Thank you very much for the like, much appreciated. Any series of the number. What is this? One, two, three. 1, 2, 3, 6. Oh, right. So it's basically 1. First you have 1, then 1 plus 2 is 3. 1 plus 2 plus 3 is 6. 1 plus 2 plus 3 plus 4 is 10. Okay. So this is what there's. I don't know why I didn't understand it the first time. It's just quite weird explained here. I don't know what the fuck are they talking about. So if 4 is given, we should have 1 plus 3 plus 6 plus 10. Okay, so what's going to happen here? Let me copy this function in Visual Studio Code. Hello Vishal, how are you? Lol, what are you talking about? Didn't you see that they gave me a problem of 7 Caillou? That was like kind of weird. But this is the thing with these challenges. Sometimes they say they are easy, but they're like sometimes they put problems that are not that easy for 7 Caillou, and like you have to think a little bit about them. And I really don't want to do that kind of thing on live. Like I mean, in the job sometimes you may get like where you have to think for 30 minutes maybe to come up with a good algorithm, but I really don't want to stay 30 minutes on the live being like hmm 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 you know. um right, so let me copy the starting function, and basically this starting function should return the sum of triangular numbers until n. All right, so basically given n we should return the sum of all these numbers. So the first one would be 1, the second one would be 3 because it's 1 plus 2, then the third one would be 6, because it's so on, right? So we need to return the sum until n. So I think we can look at a pattern here, because if we look at this, we basically get something like this. We're basically getting n, or n multiplied by 1 plus n minus 1 multiplied by 2 so n minus 1 multiplied by 2, and then plus n minus 2 actually we get n or 1, and then we get n minus 1 like this multiplied by 2, then we get n minus 3 like n minus 3, wait, n multiplied by 1, n minus 1 multiplied by 2, and here is n minus 2 multiplied by 3, and so on until the last one, right? Until the last one is basically 1. So what we can say is, how are we gonna do this? Well, the last one in this one would be basically plus n minus 3 multiplied by 4. And if you can see, this 4 is actually this 4 is actually the value of n in this case, because the value of n in this case would be 4. So what we can do is we can say let multiplier, which the multiplier is this, basically the one on this side, and we want to start that one from 1, right? And then we want to say while, so this one would start from 1, so we can say while multiplier is different than, actually is less than or equal to n, because we're still gonna have this one when it's n as well. So while is less than or equal to n, what do we want to do? We want to basically start from a sum that's 0. So we're gonna have a sum, let sum equals 0, and what we want to do, this is 0. Let me remove these ones because we don't need them anymore, and I'm going to comment this just for a while. And what we want to do is, while multiplier is less than or equal to n, we want to say sum is equal to sum plus, and what we want to do is the multiplier, which would start with 1, as you can see, right? Sum plus multiplier, and this multiplier would be multiplied with n, and this n would be, we will subtract from n the multiplier minus 1. As you can see, the first time the multiplier is multiplied by n minus multiplier minus 1. Multiplier minus 1 is 0, so n minus 0 is n, so it would remain n, and then multiply by 1. Then when the multiplier becomes 2, then we multiply it by n minus 1, which is the multiplier minus 1, and so on. So we basically say sum equal to sum plus multiplier or n minus multiplier minus 1, which is basically n minus multiplier plus 1, right? If you do it like that, right? If you basically reduce this, like in mathematics, this minus inside this parenthesis, if you take this off, it becomes plus. All right, and then at the end, we just want to return this sum. So this is very simple. We can just delete this, and here you can write this one like sum equal to sum plus something. You can just say sum plus is equal to this, and we return it. So let me copy this. Let's test it. Okay, we did do a mistake because after we do this sum every time, we want to increase the multiplier by 1 because it needs to become higher until it reaches n. Otherwise, it will not reach n, and this will be an infinite loop, right? Multiplier plus plus. All right. So let's copy this and put it here, and this works, and this works. All right. Vishal, yes, I did start early because I felt that maybe a lot of people can't do it later, so I thought I'd give it a chance at this time as well. And also it makes it easier for me to have the dinner at the usual hour I have it, because usually I have dinner about 6 o'clock, and if I have to start live at 7 o'clock, then that's basically kind of not working very well. All right, let's do another one. Okay, let's do a simple one. Now that the one before wasn't quite simple as well, but let's see. It says in this kata you will remove the leftmost duplicate from a list of integer and return the result. So basically you have in an array some duplicates and you want to remove all of them that are the first one. So you want to leave the last one where it is, but remove the ones before. Okay, so but for everything that's for all of them, you just want to remove the ones that are from before and leave the last one. Okay. Uh, so let me copy this. Where is this function, right? And let's copy this example as well. I'm gonna comment it. So basically what you have to do is go to the array, remove all the duplicates that are on the left side. Okay, so what we can do is let me think, how are we going to do this? Do, do, do. Mm, this is an interesting one because if you remove if you just first find all the indexes and then you try to remove one and then remove for the other one, that one won't be at the index that it was before. So I'm wondering how a set works, because there's something that you can do to remove duplicates from an array. You can basically say a new set of, and you give it an array with duplicates, and you would keep just it would keep just the, but I think this one will not work well because it will remove the duplicates from the first duplicates or something like that. But let's see how it actually works. And so basically I'm gonna try this. I'm gonna to try to basically return, but I don't know if it says return the result. Okay, let's return. Basically we're gonna spread in an array a new, because the set is not actually an array, is another data structure. But probably this is not gonna work because I don't know exactly how this removes the duplicates. New set of array. So let me console log solve of this and see what we get. Clear. And we actually get 346, which it was expecting. Yeah, so basically it just take the first one but not anything after. So I'm just wondering if I say new set. I mean, this one, if I do it like this one would not be this one would not be performant as well. But what I could say is reverse this array first, so it will start from the other side, and then after I get a set in an array, I would reverse it again. But this way it wouldn't be very performant, so we need to write another one. But this would be like a really brute force one. So as we can see, we get the 463 if we do something like this, but it's not very good. I mean, obviously, like, we could put it in here and it would work, as you can see. So it does work, and it doesn't seem to get to take that much time. It only gets like, well, 859 milliseconds is quite a lot, but it depends how many tests there are. There are quite a few tests. Good. So let's see what the other solution would be. I'm gonna comment this one and try to think of another one. Well, since we're returning a new array, um, well, what we could do is basically, I mean, this one would not be very good as well, but what we can say is create a new array, const Unix equals to empty array, and then what we can say for let element of, I think is off when you use array. I always confuse it which one is for let off or let in, which one for let off, which one is for objects, for off is for, yeah, so this one is for array. So let's say for const element of I think what we need actually, I will not use this because I think we need to go from the end to the beginning. So what we want to say, actually what I'll make, for I mean, I'm trying. I'm trying now because I know what to do, but I'm trying to think of an even more clever solution. But let's just do like this. So we're gonna say for let I equals 2, and we want to start the array length -1, which is the index of the last element. And we want to say while I is higher than or equal to 0, which will be the first index, I minus. And then what we want to say is in here, we want to say if Unix, if Unix includes if Unix includes array of I, which is the one we have at the moment, it means we have already pushed it in there. So if it includes this, then what we want to say is we want to skip to the next index because we already had an added in Unix an element with that value. So to basically go directly to the next iteration of the loop, you can use continue, right? And if it didn't continue here, which means it's not included yet, then what you want to say Unix, and you want to push, and you want to push it because, do you want to push it? No, you don't want to push it, because if you push it, you get the elements that are from the reverse, like from the end of the array, you push it and then you get the next one, so you will get them in reverse. So instead of push, you want to use unshift, which means it pushes us from the beginning of the array, and that way the one that was the first one pushed in, it will be at the end, how it's supposed to be, right? So you want to say Unix unshift, and we're going to unshift array of I, and then we want to return Unix. Why did I do that? Return Unix like this. So let's put this in here. Let's attempt it. And as you can see, this one works as well. And it seems it has about the same time like the other one, because it basically uses a lot of include, so it's still taking a lot. Let's see if we can make it a bit more performant. I don't know if you can actually make it more performant here, since it has so many calls. But one thing that we can improve on performance here is we can actually keep track as well of the unique elements in an object. When we find one that when we find a new one, we just add it. So we can say const keep track equals to an empty object. So what you want to say is, instead of checking if it's included in this array, that doesn't matter, because if you check if it includes, it basically goes to the whole array. What you want to check is if keep track of array of I. So if that one exists, it means we already put that unique element in the object. So the advantage with this one is that instead of looking to a whole array, you're basically just looking at one position in the object immediately, and if it's there, then you know you already found it, right? And why are we getting an error here? If keep track of array of I. Oh, I have an extra parenthesis here. Continue, right? But to keep track of these things in here, on top of this one, we also want to do keep track of array of I is keep track of, this is an object, array of I equals true. So basically when we find a new unique one, because it says like if we already found it before, then we just continue. If we didn't find it, then we want to add it with true. So here, instead of doing include and going to the whole array, we're just looking into an object immediately. Now let's see if this one actually does something in terms of performance in here, but I think in real life it would be an improvement on performance. So let's test it and let's attempt it. And it does actually make a difference. You get just 812 milliseconds here. Let's try it again. Let's say, and let's refresh again. Now let's try it one more time and see if it's the same result. Attempt. It's still less, but test. Let's put again. Let's refresh one more time and see if it gets the same. I do think it's more performance, so that might reflect in this thing. Yeah, seems to be more performant. So let's submit it. The time here visual is 4:48. Yeah, I'm basically trying to go through a few. Sometimes it's good to go through some interesting solutions. All right, let's go to another one. Maybe let's move to some 6K ones, even though these people actually put some weird ones even in the 7K ones. Let's see. This one maybe digit recovery. Oh my god, what is with this long? Okay, some letters in the input string are representing a written out digit. Some of the letters may randomly shuffle. Who write that? Some of the letters may randomly shuffled. Your task is to recover them all. I don't understand nothing from what it says here. Only consecutive letters can be used. What cannot be recovered to 1? Every letter has to start with an increasing index. 1, no. Result to 11 because the E can be used 2 times. This is a weird one. Every letter has to start with an increasing index. What the heck are they talking about? If there are letters in the string which don't create a number, you can ignore them. If no digits can be found, return no digits found. Take care about the order. And a note will be recovered to 12 and not to 21. 2, 1. Okay, this is very weird. The input string consists only uppercase letter. How can be this only 6 KU? Because this one seems quite involved. Mm. So for example, you get 1, then you get 2, so the last one actually can be used for mm, for the next one as well. Then you get name 2, 1 again, 1, but you can get 2 here, then another 2, and then on 1. What? Oh, this is just very weird. So 2 from here and then 2 from here. Oh, 2. What? Oh, I get what's happening. So for every letter you can go up to until you find like a digit, and like the kind of the letters for a for a digit, and once you have found those, you can go back to the one before. I see what's going on here. But yeah, okay, let's copy this in here, and I think what we can do, okay, let's copy this, clear this, and they give us this const alphabet. So let's copy this somewhere in here, and I think what we want to say is we want to first we want to say const letters of string, and we can make an array of this by putting an array and spreading this string, which is gonna give us an array of all the letters in here. And then what we want to say, we want to start with the first one, and we want to say for, actually we want to do a loop, and we want to say for let I equals 0, I less than letters of string length, which basically goes until the last index I plus plus. And what we want to say is let index of letter, we want to basically store this value here so that we can increase it. So the index of this letter is I. Then we want to say let new digit will be starting with it will be starting with an empty string, and here we'll basically gonna add letters from this particular letter in the string. We're gonna keep adding letters until we find the letters for a combination, like a kind of, how you call, permutation of one of these digits, right? Now before this I want to basically basically I think we need to write let me look at this how it is. You get on your text instead of mobile. So obviously this is really not just a 6 Caillou challenge for sure, but I wonder if there is a function, probably not, but I was wondering if there's a function for permutations in JavaScript. JavaScript permutations of string. This is probably just a function written up by someone. This is quite interesting because you basically have to write a function for that one for permutations, which is definitely not 6Caillou. Am I overcomplicating this problem? Let's see what the discussion say. There's like 18 in the discussion. Proud I got this one. I think I'm gonna look at the solutions for this one because I want to see if it doesn't seem this. Let's try to look at some solutions and see what they're doing, because I don't see any solution. So probably my thought was wrong, that we need to find permutations. So it says let res equal an empty string for let I. This is where I was going as well. Then it's saying for const num in alf, which is basically one of these, const temporary equal to string slice I plus num name split sort join. What is this? These solutions are so weird. Obviously this is a weird problem. Okay, let's look at the first one again and let's try to understand it, because obviously I don't think it does what I was saying, like the sorting. Doesn't even seem to. Oh, alf. Where is he using the alf from here? Because it just assumed that the alf is given probably. So let me go back and let's say that we have this one so that we understand what's going on. I'm gonna close this for now. Okay, so what is it doing is digit. What is the digit? What is this saying that the digit is? Oh, this is using some kind of recursion. But what is this digit? Shuffled. Digit sort join equals to. What does this do? It's just checking something. Oh wait, consequence. Oh, okay, so no, this is not recursion. What am I talking about? It's just making basically something that checks between two things. Is checking if digit sort. Oh, I see. This is quite nice. What I was talking about, yeah, you don't need to sort it, because basically, if sorted has the same letter, then it means it can make up the words. So you don't need to find all the permutation. So what this finds, it finds if two basically two values, if you give it two string, it basically sorts the letters of that string and see if the sorted string from the first one is equal to the sorted string of the last one, which if it is, it means you can make up the first word from the second word by permutating it. So this is quite nice. So we can use the same thing well, let's not write it again, but basically this is what this checks. So it's basically kind of checking if they're equals as a permutation, and then the results start from an empty string. You go like we were saying from I to 0, and then you say for const digit of object keys of alf, which means it takes all of this by 1 and is checking if sequels of digit, which is the string, sequels of, well, it's not a string, digit is this particular thing that we're checking, and string slice of I, which is the current one, and I plus digit length. So basically is going from I to the digit length from here, and if these two are equal, then result plus is equal to half digit, and we're breaking at this point so that we don't go through all of this. And then at the end we're returning result or no digits found. If there is no result, like if the result is still empty, which means it didn't find any digit, then we're returning no digits found. So yeah, I understand the solution. I think where I was messing up is that I was thinking that I have to find all the permutations, but you don't have to. You just have to find if one string can be a permutation of another. You don't have to find all the permutations and then check if that string is in the permutations. Alright, I think I'm gonna stop here for today, and probably the next live that I will do will be one in my series of going to the free codecamp course. I'm almost at the end of the JavaScript algorithm and data structure course, and you will see me getting the diploma or whatever, the certificate live in about 2 or 3 lives. If you're following that live, you can join as well then. And I think I will do another coding challenges live soon as well. So if you like these ones, please make sure to join, and I'll see you next time. Also, if you didn't give a like already, I would appreciate one, and good luck. Bye for now.